In this discussion video, we will do a differential equations example of an applied situation. So this is problem 4 from worksheet 13, and it says that a bungee jumper is jumping out off a bridge. When she is 100 feet above the ground, the bungee cord becomes taut and begins to decelerate her. The acceleration, which is upwards, for time t seconds after the bungee cord becomes taut, follows a of t equals 6 feet per second squared. And she momentarily stops while 50 feet above the ground. A asks, how fast was she falling when the cord became taut? B asks, how long does it take for the taut bungee cord to take her from free fall to stopping? Okay, I want to first give you 6 minutes to try this. Pause the video in 4, 3, 2, 1. Pause it for 6 minutes to try this question. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 6 minutes. Let's talk about it together. So I think for this problem it would be helpful to draw a picture. So in the scenario we have the ground, and then it talks about some bridge. So maybe I'll draw like 2 cliffs, a cliff here and a cliff here, and there's some bridge. So let's draw a line for a bridge connecting them. So we have this bridge. And then from that bridge, we have this person who is going to be attached to a bungee cord, who's going to jump off. So they're attached to a bungee cord, and at some point, the cord becomes taut. When it's taut, they are no longer in free fall, and the cord starts to slow them down. At this instant, the problem says they're 100 feet above the ground. Okay, and then they continue to fall. So I'll draw dot, 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 dot. They continue to fall for a while until they reach a point where they are 50 feet above the ground. And once they've reached that point where they're 50 feet above the ground, then they've completely slowed down and they momentarily stop, and then they'll come back up. Okay. All right, so let's now write down what are some of the things that we know. Well, the problem tells us the acceleration, a of t, equals 6. Units are feet per second squared. I'm just going to keep that in mind. I also know that at this point when they are 50 feet above the ground, oh, by the way, okay, so in these questions that involve a position, a velocity, acceleration, it's helpful to know where my reference point is. And my reference point for height, I'm going to say, is at the ground. And I'm going to say this upwards direction is the positive direction. So I'm going to have the positive direction. And that is upwards. I can also tell that that is going to be the positive direction from the context of the problem when it tells me that the acceleration is upwards, and when it says the acceleration is 6, that's a positive number, which means we're thinking about this upward direction as positive. Okay, so, well, what we were saying is at this moment when this bungee jumper sort of momentarily stops moving, they're 50 feet above the ground. So that means their velocity is 0 because they momentarily stop when the position or the height is 50. So this is the instant where they momentarily stop. Okay, one other piece of info that we know is at that instant when the cord becomes taut, we know their position. So if I call their position function s, or maybe I could call it h, but I know s of 0 because the time is measured starting when the bungee cord becomes taut. S of 0, that position, is 100. They're 100 feet above the ground. So those are the things that we know. Then the question is asking, well, it's asking how fast was she falling when the cord becomes taut. And it's also asking how long does it take for the bungee cord to take her from free fall to stopping. So in other words, how long does it take until she momentarily stops? So in part A, it wants us to find a velocity. How fast was she falling? When the cord becomes taut, that's when t is 0. Okay, so we are going to have to get the velocity function. Remember, the velocity function is the antiderivative of acceleration. So antiderivative of 6, and then I put a dt. Alrighty, and now This antiderivative is 6t plus c, because it's a general antiderivative. All right, and from there, I can form the position function. Actually, before I do that, maybe I should just say, well, the question wants v of 0. If I plug in 0 into this, I get 6 times 0 plus c, which is just c. So I need to figure out c somehow. Okay, and based off of some of this initial information that's given to me, it tells me some of the stuff. It tells me other information about velocity and position. So let's get the position function. So position is going to be antiderivative of velocity of 6t plus c. I read a dt. Okay, so this antiderivative 6t is 3t squared. Antiderivative c is ct. And then I have to put a plus d. I get another constant when I do this antiderivative. Okay, so now let's try to use this other given info. So maybe I'll try to use the s of 0 piece of information. So the s of 0 information tells me that the position, or the height, when t equals 0, t equals 0 is when the chord initially becomes taut, is 100. And if I plug 0 into my position function, we get 3 0 squared plus c times 0 plus d, and that equals 100. Okay, so that tells me d is 100. Okay, so we know d. We need to somehow get c. So maybe I'll use this other piece of info. The other piece of info tells me that my velocity is 0 when the position is 50. So this is sort of telling me two simultaneous things. I need my velocity to be 0 at the exact moment when position is 50. Okay, so let's set the velocity. Let's set the velocity, which is, well, let's do position first. So position is 3t squared. 3t squared plus ct plus d, which I now know is 100. Let's set that equal to 50. That's got to be the case. And the velocity's got to be 0. So now I'll set my velocity equal to 0. 6t plus c will have to be 0 at this time, the time when this happens. Okay, so if I rearrange the second equation, I get c equals negative 6t. Now we can sub that into the first equation. Doing that, we'll get 3t squared. All right, so 3t squared, if I plug in the c value, we'll get minus 6t squared. And if I subtract 100, we get minus 50. So the left-hand side simplifies to negative 3t squared equals negative 50. So t squared equals 50 over 3. All right, so t squared equals 50 over 3. So if I square root both sides, we get t equals root 50 over 3. I don't put a plus or minus because we can't have a negative time here. So no plus or minus since t is greater than or equal to 0. So what we found, this is the time at which the person momentarily stops, when their velocity is 0. And that was the answer to part B. Okay, so I'm going to box this. So this is the answer to part B of the problem. So from here, I'm going to leave this for you to finish. So we are almost done, but I want to give you an opportunity to try to wrap this up.